This is the fourth question in the series and we are discussing to remove duplicates from a sorted array second. So what we have to do is we will be given an array and we have to keep at most 2 duplicates. That means if a number is getting duplicated twice, that is fine, but 3 numbers cannot be there. And we have to remove the duplicates in place. That means space complexity should not be there. Relative order of the elements should also be same. And then we have to remove, after removing any element that is happening more than twice, you have to return the number of elements that are left, which is you have to return k after the final result. If you see in this array, 1 is present 3 times. So what we have to do is we have to keep it only twice. 2 is present 2 times, it's fine. 3 is present once, that is also accepted. So how many elements are left? 5. Same way, see in this array, 2 times 0 present, fine. 1 is present 4 times, you will keep it only 2 times. Then 2 is present once, fine. And 3 is present 2 times, that is also fine. So the number of elements is 2, 4, 6, 2, 4, 5, 6, 7. So 7 are the number of elements left after removing any element that is present more than 2 times. So the approach to this question will be similar to the one that we did in the last video. You can go and see that once also, where we were removing all the duplicates. But now we have to remove the duplicates, but it is fine if some element is present 2 times. So for that, what we can do is we can maintain a count. I will show you how to do that. So what we have to do in this two-pointer approach is that initially what we will say is the k value is 0. Similarly, for every time we will say count value is also 0. And we will keep one I value also there. I will keep on iterating full array. Every time we will increment. So what we will say is if I value is on 0, that means this is the first element that we are going to count. So we will count as 1. And if there is a new element, like for every element we are keeping count and it is sorted array. So whenever one element is not equal to the previous element, we are all the times resetting the value of count. See here, if nums of I is not equal to nums of I minus 1, that means there is a new number that is coming up. We will reset the value of count so that we are counting it from a new point. That means we will again check if there are 2 elements or not. So count is 1 initially. Then what we are going to do is we will compare number of I is not equal to I minus 1. No, it is not there. So if number of I is not equal to nums of I minus 1, that means next element is same element. We are incrementing the count. So count will become 2. If count is less than equal to 2 at k value, you will simply keep I value and increment k. That means when count was 1, what we have to do is we have to take I value, nums of I value which is 0 and keep it at nums of k which is also 0 index. So simply it will be 0 only. And then I will come here. Count, as I said, I is equal to I minus 1. Simply count will be incremented. So check. K is also incremented, right? Because it was less than equal to 2. So at kth index, we are again putting the value of ith index. That is again 0. So 0 is 0 only. Then we will increment I also, and same way we will increment k also. But this time nums of I is not equal to nums of I minus 1. That means it is a completely new element. So count will be reset to the value 1. Then then check count is less than equal to 2. Yes, this condition is true. At nums of k, you have to keep the nums of I value, which is 1 only. So 1 value we will keep, and then we will increment k, then we will increment I. Again, compare I to I minus 1 value. They are both same. So we will increment the count. Count is still less than 2. So at kth index, which is 3, increment I value, which was also 3 index only. So now we have incremented I also, we have incremented k also, but this time nums of I is equal to nums of I minus 1. Increment the count will be 3. Again, this time count is not less than equal to 2, so condition is not true. We will increment I again, right? When you increment I, compare I to I minus 1, it is still equal, so count will be 4. Count is not less than equal to 2, nothing. This will not work. So then only I will be increment again. This time you check I is not equal to I minus 1 value. So count will be again reset to 1. If it is 1, then again it is less than equal to 2. So at nums of k value, you will replace it with the value of nums of I. So here you will place the value 2, and simply then you will increment the value of k, and then you will increment I value. Again check I is not equal to I minus 1. So what you have to do? Again, the value of count will be reset to 1, and count is less than equal to 2. So at nums of k value, you will add the nums of I value, which is 3. Simply increment k, simply increment I. Check nums of I is equal to nums of I minus 1. So count will be count plus 1, which means 2. 2 is still less than equal to 2. This condition is true. At kth index, I will add the value of ith index, which is 3. And then I will increment the value of k. I will stop because it has reached to the end, and k value is 7. So I will return the value of 7 from this question. I hope you have understood. If there is any doubt, you can go through this tracing again. You will understand better. We are counting of every single unique element. If it is coming, if the count is more than 2, we are not replacing the value of k with I, otherwise we are replacing. Thank you, and I will share the solution of this code of LeetCode also through my GitHub account for all you guys. Subscribe to my channel so that I can make more such videos. Thank you.